And normally I would invite you now to join our exhibition. As we don't have a physical exhibition, we have a digital exhibition, and this is done by video clips, short video clips. They're supposed to be a minute plus-ish. And I'm happy to have, say, at least the speakers giving comments to these video clips. So we look at the video clip, we have a comment, 2 minutes, and then we go for the next. And if that is done, let's say in 20 minutes, we allow everybody to go for getting a coffee or a small break, and then we see each other again. Bastian, you're the DJ. Can you start with the first video and tell us which one it is? You're muted.
Okay, now you can hear me?
Yeah, perfect.
Okay, so first video is by Crate, Southern University of Denmark, led by Roberto Narboni.
Okay, thank you. Small applause. Is someone from SDU here in the audience? Somehow raise your hand or make us being able to see you. Interesting to see that concrete is the material which is the most, which we see a lot. And the plastic obviously was the one which was actually first, but we're still hesitating in construction how to deal with plastic as a material. So it's you see now at some places on an say larger scale this material being brought to construction. That's yeah, that's what I predict. And here, as I understand this video, this is about recycling as well. Anyone else of the speakers to comment to this? Okay. Well,
maybe I'll just jump in quickly then and say, look, I think this has a lot of potential because printing with, well, firstly, printing with recycled materials, I can see a lot of benefits in doing this, but it's a very rapid, very reliable printing process that does have quite a lot of geometric freedom within it. And using that as the capacity to make formwork for then casting other materials. And this goes back to some of the early presentations today about printing one material and casting back into it. I think this type of permanent or sacrificial formwork strategy is a kind of really fertile area for exploration within additive manufacturing. And quite beautiful results.
Good comment. Bastian, next video.
Okay, next video is TU Delft, Double Phase 2.0 by Architectural Engineering and Technology.
Another one in plastic.
Yeah. This one doesn't have sound, so.
Okay. It's actually a group of mainly hosted by two people, Michela Turin and Martin Tempirek, starting with solar harvesting systems printed in plastic, small bricks, increase the size of the printer to a certain dimension. And this project, if I'm remembering it right, is including one side filled with water and the other side filled with phase change material, and then being positioned in an experimental place to be tilted during the time of being used. And I remember they had very hard times to get it really watertight, which you can imagine with the printing process of the plastics. What I like with this theme is that it's not, again, just another material or a material to replace something, but it tries to integrate this additional functionality of being able to have water flow through the system in this setup. Roland, you're my secure counterpart.
Yeah, well,
we need to get the audience more active in this.
And I'm happy to talk about this. I mean, I've spent many years trying to work on large scale printing of polymers. And I guess one limitation that you can see in this project is that the start-stop on printing with polymers is often really problematic because it drags the material, so you get all these kind of like fine fur in it. But also, that's the problem, that getting the water tightness probably comes down to that problem. It's the start and stop of those, and getting those to be completely watertight is a kind of hugely problematic part of that kind of process.
Yeah, but I'm happy to have this project in this exhibition, in this virtual exhibition, because we're really looking forward. But it was too large to get it transported last time, so I'm happy to have it in here this time. Bastian, next one. Ah, that one, yeah. You're muted, we don't hear you.
Okay, sorry, yeah. Space Shingles is the project by Leibniz University Hannover and Hochschule Wismar, Professor Mirko Becker and Asko From. Again, no sound.
Actually links to the project which we saw from Zurich with these interconnectors. Remembers me also to a very early interconnector project Marcel Bilo from Delft was doing when he was scanning a 3D brick and adding a shelf to that as an action. Interesting, obviously, is going to be, is it, say, purely geometry driven by the design, or is it linked to the geometry really existing, and how to then connect the components? Oh, cast it.
Yeah, that's something we also saw with the last beam, yeah, like this sort of mixed methods, yeah. 3D print the object and then cast it afterwards to really get some of the material strength,
which we are more used to and more, say, feel reliable in the means of construction. Yeah. Nice little objects, clear. It actually also has a structural performance potential.
I mean, there's a certain relationship here to the work that Ines is doing in terms of the WAM printing. And I was kind of curious, certainly with Ines's work, about the relationship between, are they parametric components which get modified based on the exact nature of the location of the geometry, which these appear to be, or in her case, is it something which is entirely procedurally generated and could actually take potentially any condition? So is it generated through, say, for example, topology optimization or whatever generative process? And then it can take any kind of input and create an optimized joint for that. I think these are kind of two very different ways of thinking about this. Do you have something which is designed, which is then modified, or do you have something which is entirely generated from its particular conditions?
Yeah, clear comment. Nice little project. Thank you. Bastian, next one.
Okay, yeah, TU Munich, chair of timber construction and building construction, as well as material science and testing.
The concrete environment. Here we go. Bastian, are you aware of if this is still the wood fiber reinforced concrete?
No, I do.
You remember they've been presenting,
Yeah,
let's say, in the second beam, and at that time they were with this wood fiber reinforced concrete. But and as I see Winter being here, I thought this may be still the case, but I couldn't identify from the video itself. And also have to say, I think another challenge which I see at some places next to the technical way of how to do the prints and what the performance is, the surface also appears to have a certain aesthetic. And I think that's going to be also something which we will see more frequent in, say, the use of this technology to also deal with the appearance of the surface in an aesthetic view, in an aesthetic way, because that's, say, delivering opportunities like patterns in the surface. Roland, you want to comment to that?
Oh yeah, look, I think that's a fascinating thing to think about, because obviously this layer-by-layer 3D printing has such a recognizable fine-grained aesthetic to it. And I guess when a certain aesthetic is tied to a certain technique, it always risks becoming cliche at a certain point or becoming fairly dated. So I wonder.
Well, let's play with some cliches as well. Why
but
not?
Yeah, I wonder how many years' time it'll take. Like, not many, I predict. If we look back at that and go, we see that as a trope or something. So I'm quite interested in what are all the sort of post-process possibilities of this. And the work that we're doing with WAM right now is, obviously you can leave WAM as a layer-by-layer recognizable thing, or you can, of course, mill it back. There's so many different things you can do to that to get different effects. And I think that that becomes a really interesting area. Like, are you going to simply accept the kind of generic condition of it, or are there a whole lot of other processes that we need to do in order to be able to kind of like create a sort of broader range of effects?
Yeah. Thanks for the comment. You're saving me, Roland, to have at least some interaction here. Bastian, next one.
Okay, yeah, next one again, TU Munich. They have this big, what is it?
Sonderforschungsbereich.
Sonderforschungsbereich, yeah.
Yeah.
So
they actually link to Braunschweig, and Norman Hack is going to give some presentations on this as well. And it's mainly about 3D printing concrete for the construction. Huge project, huge funded research. Very nice.
Here we have the project Selective Cement Activation. Yep.
This was obviously entirely different qua noise. The other opportunity to deal with concrete, when we look at in the booklet Bastian made, we find other objects as well. And I have to say, it actually the nice part of this one, a significant number of compressive loads that could be taken by this, which makes it interesting. And I think, Bastian, we're going to have another one from them, do we? Yeah, let's do that one as well, and then we
in a row, yeah. But this one seems to be without sound. So, yeah.
Okay. Yeah, same general outline of say having the layers to create the volume. and by that being simply able to have more three-dimensional geometries. That's the one part. I'm not sure about this project, if it is, say, purely concrete, or if there's a binder within the lamination process. Bastian, you know more. Body language was saying that you know it.
Yeah, I mean here the special thing is the binder, yeah, that allows you to combine different materials also, yeah, as a compound material here, yeah.
That's why.
And I really enjoy that. I mean, this technique allows you to really do fabricate really complex shapes. Yeah, you can have undercuts and stuff like that. So yeah, it's definitely also an interesting approach.
Again, when we look at the in the booklet you made, you see them being. You see this complexity which is possible. Roland, give it a comment from your side.
Well, from somebody who normally, I spend most of my time working with extrusion printing techniques. I'm always incredibly jealous of the geometric freedom that's possible in powder bed printing. I mean, the limited amount of sort of SLM work we've done, we've sort of tried to push the limits of what is possible in terms of geometric complexity. But I think there's so much potential in these type of powder-based processes, and probably for those processes, really tackling and pushing to the limit what geometry is possible with these, I think is really interesting.
Maybe when we follow Professor Jan's idea of combining technologies, that's one of the next things we may see in the next years, getting these techniques combined. First the one, then the second, or maybe even in process combined. Interesting to see. Bastian, how many more do we have to go? Bang, here we go.
It's two more. Yeah, sorry, this is the project Green Facade by Vertico, research department, yeah.
Saxony means the north of the Netherlands. That's where they are located, as far as I could investigate. One of the applications, possible applications of 3D printed concrete, I would say. Roland.
I guess the thing I'd say about this is that it highlights the one potential benefit of using prefabricated elements over in situ printing. I mean, we sort of know that this type of geometry is not really possible with concrete printing in the direction that it's installed in. Yep. It's only because it's obviously printed in one direction and can be installed in another direction. And I think that although it's relatively simple in this particular case, like it's just flipped in one direction and they're all flipped in the same way, I think using these types of strategies where you take the limitations in the factory and you change how they operate within the design on site through simple things like orientation.
Have you ever seen, say, a horizontal printed in concrete and then tilted and then continued printing? Because that's what actually Ines showed with her WAM layouts, not only in one direction, but also in a certain angle. And have you seen that in concrete?
No, certainly not in concrete. I mean, I guess one of the amazing things about WAM is, of course, you can, under certain conditions, you can even print WAM upside down. Always works much better.
That's a bit more complex with concrete, but you can imagine that, say, tilting it and then continuing to printing, then you again get different geometries, as I said. So
there's obviously a lot of work where the workpiece is on a 2-axis turntable, for example, so it can constantly be orientated in order that you're printing up. And I think that that has a radical impact on the range of geometries and the sort of overhang or draft angles that can be achieved in sort of extrusion deposition printing.
Clear. We do the last one, and then we are good in time to still have a break.
Yeah, last one by our next moderator in the next session, MX3D guys handed that in. Yeah.
Thank you. Is Gijs, are you still here?
Yeah, well, I wasn't listening in, but I saw the video. So
well, I think you know the video, don't you?
Yeah.
So what's up with this one? It's a steel structure, and then you fill concrete inside. For what purpose?
Yeah.
Additional compressor strength. I
yeah.
guess.
So it's I mean. So the concrete was not is going to be more interesting when the node becomes much bigger. So now we just want to show the concept. So we've printed several more nodes now, and they're being destructive tested in Takenaka now. So we can so these nodes are bigger and they have bigger hollow space. So we can validate whether the assumptions are right, and so the Japanese are still very interested in bringing it a step further towards implementation in the actual project. So that's what we're working for now.
Do you see Takenaka being say as a major construction company be really into it to bring it to a level where they really get it to construction site?
Yeah. So they've ordered quite a few projects from us, and with the Japanese companies, we see that once they're in it, they go all out. We have a couple more under NDA, but so they really once they decide to do it, it takes like 1 year before they decide to do it with 100 calls. But once it's there, they really go for it, and they have the budgets, and I definitely see them taking it to the next step. So not so much the experimental part, but the testing to get it in real use.
Which is interesting, because then it's not a brand. Oh yes, we do also this 3D printing to make the world better, but de facto not really doing it. But if they really go to that one, because I'm aware of, say, their prefab, automated prefab manufacturing they did in the 80s and 90s. And in that respect, I would expect them to be, well, if they go for it, serious. And that's how you comment. Thank you for that. Yeah. Roland, do you want to give a word on this one as well?
I will drop out. I don't know.
No, just stay here for the last 2 minutes, and then we can take a break.
I think it's it's a fascinating project and a kind of really interesting strategy. I mean, obviously within building construction, permanent formwork structures are really common. Like in terms of, so I don't know. I mean, certainly in Melbourne, where I'm based, there's a lot of buildings that are built with either beams or columns which are made from thin-walled steel, which are brought to site and that used as permanent formwork and cast concrete into it. And I think the idea that those things can, of course, be metal printed to enable, particularly with complex joints, as you're showing, to enable a lot of geometric freedom and dealing with some of the complex parts would normally require sophisticated welding. I think this is an area that's got a lot of potential.
Great. Now we do the break. The break works that Bastian sets all the videos in a loop, so there's a constant entertainment on this channel if you'd like to look at it. And let's say in 25 minutes we're going to be back in this channel, and then my colleague and friend Oliver Tessmann, who's in this session since 2 hours, 2.5 hours now, is going to take over with Gijs the second part of this event. Thank you for this to the speakers to give these performances. Thankful for the audience to stay here, and yeah, entertainment for 25 minutes, and then we are back.